All right, so today we're going to talk about HR diagrams, or Hertzsprung-Russell diagrams. Hertzsprung-Russell diagrams are named after two scientists that they both kind of came up with the same diagram at the same time. So this diagram is attributed to both of them. This first diagram up here, you'll notice that it doesn't have any dots or colors or stars on it like this one down here. That's because with this first one, I want us to just pay attention to the X and Y axis. So we're going to start by looking at the X axis. So make sure that whatever I'm writing down on my paper, you're writing down on yours. So we have the X axis, and on the X axis, we have temperature, which is measured in K, which stands for Kelvin. The x-axis is really important because the way that they graph temperature, the scale for temperature is different on this graph than how it usually is. So usually you have the lower numbers on the left-hand side and the higher numbers on the right-hand side, but on an HR diagram, it's flipped. Here on the left-hand side, it says 2,500, which is cooler, where here on the, I think I said left hand, I meant right hand side, it says 2,500, which is cooler, and over here on the left hand side it says 40,000, which is hotter. So temperature actually increases going from right to left. So I'm going to write temperature increases. If you look at the y-axis, so this is our y-axis. Our y-axis measures something called luminosity. Luminosity essentially just means brightness. So that's how bright our stars are. And the scale for brightness does increase the way that a normal scale on a normal graph would, where you have your lower numbers down at the bottom and your higher numbers up the top. You'll notice that these numbers have exponents. So we have, zoom in a little bit, we have 10 to the negative 4, 10 to the negative 2, 1, 10 to the 2, 10 to the 4, and 10 to the 6. So you don't have to necessarily be able to convert that from this 10 to the 6 into like a regular number. What you do need to know is that up at the top we have our brighter stars. Down at the bottom we have our dimmer stars. And brightness increases. So I'll just write that like this. Brightness increases going from top to bottom on the graph. Now this number 1 is really important. If you look at our unit for luminosity, it says L sun. So I'm going to write this over to the side. L sun is luminosity compared to the sun. So essentially, like, how many of our sun's bright is this star? So our sun has a luminosity of 1. So 1 is our sun, this dotted line right here. Now you'll notice that this graph has been divided into quadrants, and it says label the quadrants on the HR diagram. And we're going to label the quadrants according to their brightness and their temperature. So quadrant number 1, I'm going to label them with the Roman numerals. Quadrant number 1 is bright and hot. So bright and hot. The stars that are found in this column are bright and hot. Quadrant number 2, again I'm using Roman numerals, is still bright, but instead of hot, these are cool. Down here at the bottom, we'll do quadrant number 3. These are cool and dim. Dim and cool. And finally, in quadrant number 4, we have dim and hot. So these are our quadrants on the HR diagram, and kind of generally how our axes work. It's important that when we are looking at the different groups on the periodic, not the periodic table, on the HR diagram, that we are able to classify stars into these 4 groups. So bright, hot, bright, cool, and dim, hot. So pause it if you need to get caught up, then scoot down to the bottom down here. So this says label the groups and the sun on the HR diagram. So you'll notice that there are a bunch of circled groups, a bunch of stars of differing sizes and different colors. So the first thing that I'm going to do is what I did up here on the axes, I'm going to repeat it. So one thing that is hard to see on your notes is that different stars have different colors. So you're going to actually need some colored pencils. And it's a little bit hard to see, but you can see kind of where the colors change. There's not any exact temperatures for me to give you. You just want to kind of look for the point where the colors change. And that's where you're going to sketch in your colors. So down here on our coolest side, we have red, and that's really interesting. We'll talk about it. After red, our slightly warmer stars are orange. After orange, our slightly warmer stars are yellow. So we actually have a gap in the middle. Our slightly warmer stars are white. After this gap, our stars are blue. Our blue-white. And then we have just blue stars over here on the far left-hand side. So your hotter stars are actually blue, and your cooler stars are actually redder. Bluer. So this is kind of against what you guys might traditionally think. It has to do with something called the EM, or electromagnetic spectrum, which we'll talk about later on this year. So right now you just need to remember that stars are kind of opposite how we traditionally think, where the cooler stars are redder and the hotter stars are bluer. So now that we've got our axes labeled, we're going to label the different groups on the periodic table. So we're going to start with this big diagonal section in the middle. This is called the main sequence. So down here we have, again, the main sequence. That's this very large diagonal portion. And this dot right here in the yellow section is actually our sun. So our sun is a main sequence star. Up here in this kind of red, orange, yellow area, right above the main sequence, these are our giant stars. Up here we have a big group. These are our supergiants, and our supergiants can kind of be in two categories. You have cooler supergiants, which are our red supergiants. And then we have the hotter supergiants, which are our blue supergiants. And then finally, we have our last group down here. These are very dim, but they're very hot. And these are our white dwarf stars. Note that some of these groups, for instance, the red giants, or the red supergiants, are going to kind of fall into multiple color categories, and that's because these are just like kind of general color groups. So white dwarfs are traditionally white, even if they fall into kind of the bluer ends of the spectrum. And that has to do with a lot of things. The main thing being surface temperature is what is going to control the color. So now you're going to do the back side, depending on which class you are in.